Hello everyone. In previous class, we discussed about what is the operational amplifier, in short op-amps, its circuit diagram, its operation and its working principle. पिछले वाली क्लास में हमने ऑपरेशनल एम्पलीफायर को डिटेल में समझा था कि क्या होता है, कैसे वो काम करता है, उसका सर्किट डायग्राम कैसे हम ड्रॉ या डिजाइन कर सकते हैं. Now, in this lecture, we will study about what is the inverting operational amplifier and the inverting operational amplifier configurations. मतलब कैसे हम inverting operational amplifier को configure कर सकते हैं. Next, we will move on the next topic, inverting operational amplifier, some examples. हम कुछ एग्जाम्पल से समझेंगे कि इन्वर्टिंग ऑपरेशनल एम्पलीफायर जो है वो कैसे ऑपरेट होता है. नेक्स्ट टॉपिक इज नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर. नेक्स्ट वन इज नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर कॉन्फ़िगरेशन. नेक्स्ट वन इज अ वोल्टेज फॉलोअर और वी कैन से दैट यूनिटी गेन बफर सर्किट्स. तो आज के लेक्चर में हम इन्वर्टिंग ऑपरेशनल एम्पलीफायर और नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर को डिटेल में स्टडी करेंगे, उनकी कॉन्फ़िगरेशन देखेंगे. तो चलिए स्टार्ट करते हैं. एंड फाइनली द रेफरेंसेस ऑफ दिस प्रेजेंटेशन. सो लेट्स स्टार्ट विद टॉपिक 1, inverting operational amplifier. So what is the inverting operational amplifier? The inverting operational amplifier is the configurations is one of the simplest and most commonly used operational amplifier topologies. We saw in the previous lecture or last lecture that the open loop gain AV0 of an operational amplifier can be very high, as much as 10 lakhs or 120 dB or more. However, this very high gain is of no real uses to us, as it makes the amplifier both unstable and hard to control as the smallest of the input signal, just a few microvolt, would be enough to cause the output voltage of the saturate and swing towards one or the other of the voltage supply rails, losing complete control of the output. As the open loop DC gain of an operational amplifier is extremely high, we can therefore afford to lose some of this high gain by connecting a suitable resistor across the amplifier from the output terminal and back to the inverting input terminal to both reduce and control the overall gain of the amplifier. This then produced an effect known commonly as the negative feedback and thus produced a very stable operational amplifier based system. The negative feedback is the process of feeding back a fraction of the output signal back to the input. But to make the feedback negative, we must feed it back to the negative or inverting input. The terminals of the operational amplifier using an external feedback resistor called RF, the feedback connection between the output and the inverting input terminal force the differential input voltage towards zero. Actually operational amplifier जो होता है उसमें हमारे पास दो टर्मिनल होते हैं, एक इन्वर्टिंग टर्मिनल होता है और दूसरा नॉन इन्वर्टिंग टर्मिनल होता है, जो हमने प्रीवियस वाली क्लास में देखा था. इन्वर्टिंग टर्मिनल जो होता है वो माइनस से हम रिप्रेजेंट करते हैं, माइनस साइन से, और नॉन इन्वर्टिंग को हम पॉजिटिव और प्लस साइन से रिप्रेजेंट करते हैं. तो नेगेटिव फीडबैक के लिए जो हमें फीडबैक देना होगा वो इन्वर्टिंग इनपुट में देना होगा. This effect produces a closed loop circuit to the amplifier, resulting in the gain of the amplifier now being called its closed loop gain. जब हम फीडबैक पाथ लगा देते हैं तो हमारा गेन जो है वो ओपन नहीं रह जाता है, सर्किट जो हमारा क्लोज हो जाता है, और उस कंडीशन में हमें जो गेन मिलता है उसको हम क्लोज लूप गेन बोलते हैं. देन अ क्लोज लूप inverting amplifier use negative feedback to accurately control the overall gain of the amplifier, but at a cost in the reduction of the amplifier gain. The negative feedback result in the inverting input terminal having a different signal on it than the actual input voltage, as it will be the sum of the input voltage plus the negative feedback voltage, giving it the label or terms of a summing point. We must therefore separate the real input signal from the inverting input by using an input resistance Rin. As we are not using the positive or non-inverting input, this is connected to a common ground or zero voltage terminal as shown in a figure, but the effect of this closed loop feedback circuit results in the voltage potential at the inverting input being equal to the non-inverting input, producing a virtual earth summing point, because it will be at the same potential as the grounded reference input. In other words, the operational amplifier become a differential amplifier. Next is the inverting operational amplifier configuration. तो इन्वर्टिंग एम्पलीफायर क्या है? इन्वर्टिंग एम्पलीफायर जो होता है उसमें हमें क्लोज लूप गेन मिलता है और उसमें जो फीडबैक है वो हम इन्वर्टिंग इनपुट्स में देते हैं. सो दिस इज कॉल्ड द इन्वर्टिंग ऑपरेशनल एम्पलीफायर. So this is the diagram for inverting operational amplifier. अब डायग्राम में हम देख सकते हैं व्हाई इट इज कॉल्ड इन्वर्टिंग एम्पलीफायर, क्योंकि इसमें हम जो फीडबैक दे रहे हैं वो फीडबैक जो हमने फीडबैक दिया हुआ है वो फीडबैक हमारा कहाँ आ रहा है? इन्वर्टिंग टर्मिनल में आ रहा है. दिस इज कॉल्ड द इन्वर्टिंग टर्मिनल एंड दिस इज कॉल्ड द नॉन इन्वर्टिंग टर्मिनल, एंड दिस इज द सिंबल ऑफ ऑपरेशनल एम्पलीफायर, एंड A is called the gain. In this inverting amplifier circuit, the operational amplifier is connected with feedback to produce a closed loop operation. When dealing with operational amplifiers, there are two very important rules to remember about inverting amplifier. These are no current flow into the input terminal and that V1 always equal to V2. However, in real world operational amplifier circuit, both of these rules are slightly broken. This is because the junction of the input and the feedback signal X is at the same potential as the positive input, which is at 0 volt or grounded. Then the junction is a virtual earth. Because of this virtual earth node, the input resistance of the amplifier is equal to the value of the input resistor Rin, and the closed loop gain of the inverting amplifier can be set by the ratio of the two external resistors. We said above that there are two very important rules to remember about the inverting amplifiers or any operational amplifier for that matter, and these are: number one, no current flow into the input terminals, and number two, the differential input voltage is 0 as V1 is equal to V2 is equal to 0, or we can say that it is virtual ground or virtually earth. Then by using these two rules, we can derive the equation for calculating the closed loop gain of an inverting amplifier using first principle. So the current I flow through the resistor network. So in a figure, this is the resistive network. Then the closed loop voltage gain of an inverting amplifier is, so the voltage gain normal हमारा जो होता है वो क्या होता है, आउटपुट वोल्टेज डिवाइडेड बाय इनपुट वोल्टेज. So we can write the equation V out divided by V in and put the value, so minus of RF divided by R in. And this can be transposed to given V out. So the output voltage, or we can say that V out is equal to minus of RF divided by R in into V in. So its output characteristics is linear. If we can draw the characteristics between the output voltage or input voltage, so we get the linear output. The negative sign is the equation indicates an inversion of the output signal with respect to the input, as it is 180 degree out of phase. This is due to the feedback being negative in value. माइनस साइन इसलिए आ रहा है क्योंकि हमने जो फीडबैक दिया हुआ है वो 180 डिग्री आउट ऑफ फेस है, इसलिए हमें वहां पे नेगेटिव साइन मिलेगा. So the equation for the output voltage V out also show that circuit is linear in nature for a fixed amplifier gain, as V out is equal to V in into gain. This property can be very useful for converting a smaller sensor signal to a much larger voltage. Another useful application of an inverting amplifier is that of trans-resistance amplifier circuit. A trans-resistance amplifier, also known as a trans-impedance amplifier, is basically a current to voltage converter, means current in and voltage out. They can be used in low power application to convert a very small current generated by a photodiode or photo detecting device, etc., into a usable output voltage, which is proportional to the input current as shown in a figure. So this is the diagram for trans resistance amplifier circuit. Trans resistance amplifier circuit क्या करता है, इसका मेन काम क्या है, काम है करंट को वोल्टेज में कन्वर्ट करना. The simple light activating circuit above converts a current generated by a photodiode into a voltage. The feedback or resistor RF sets the operating voltage point at the inverting input and control the amount of the output. The output voltage is given as V out is equal to IS into RF. Therefore, the output voltage is proportional to the amount of the input current generated by a photodiode. The next topic is inverting operational amplifier examples. तो अगर हम बेसिक सिंपल सिंगल लाइन में समझना चाहें कि इन्वर्टिंग एम्पलीफायर सर्किट क्या होता है, तो इन्वर्टिंग ऑपरेशनल एम्पलीफायर सर्किट ऐसे सर्किट होते हैं जिसमें हम जो फीडबैक देते हैं अगर वो हम इन्वर्टिंग इनपुट्स में दे रहे हैं तो सर्किट जो है वो हमारा इन्वर्टिंग ऑपरेशनल एम्पलीफायर सर्किट कहलाता है. और इसमें जो हम गेन हमें मिलता है वो हमारा क्लोज लूप गेन मिलता है, क्योंकि सर्किट हमारा क्लोज लूप के फॉर्म में होता है. एग्जाम्पल देख लेते हैं. Find the closed loop gain of the following inverting amplifier circuit. तो हमारे पास एक एम्पलीफायर सर्किट दिया हुआ है, इस एम्पलीफायर सर्किट का हमें क्लोज लूप गेन जो है वो फाइंड आउट करना है. आप देख पा रहे हैं यहाँ पे जो फीडबैक दिया हुआ है वो फीडबैक हमने कहाँ दिया हुआ है, इन्वर्टिंग टर्मिनल पे दिया हुआ है. माइनस वाले टर्मिनल को हम इन्वर्टिंग टर्मिनल बोलते हैं और पॉजिटिव जिसको हम बोलेंगे नॉन इन्वर्टिंग टर्मिनल, इसको हमने ग्राउंड किया हुआ है. ठीक है, तो हमारे पास ये डायग्राम है, इस डायग्राम में हमें क्लोज लूप गेन फाइंड आउट करना है. So using the previously found formula for the gain of the circuit, वोल्टेज गेन AB इज इक्वल टू वी आउट डिवाइडेड बाय VN, जो कि अभी हमने कैलकुलेट किया है, फॉर्मूला था माइनस ऑफ RF डिवाइडेड बाय RN। ये हमारे पास RF की वैल्यू हमें दी हुई है और RN की वैल्यू भी हमें दी हुई है, तो आसानी से हम क्लोज लूप गेन निकाल सकते हैं। So we can now substitute the value of the resistor in the circuit as follow. Rn is equal to 10 kilo ohm and Rf is equal to 100 kilo ohm. And the gain of the circuit is calculated as minus of Rf divided by Rn. So is equal to 100 divided by 10. So we get minus of 10. Therefore, the closed loop gain of the inverting amplifier circuit above is given minus 10 or 20 dB, or we can say that 20 log 10. तो इस तरीके से हम बहुत आसानी से जो है वो क्लोज लूप गेन कैलकुलेट कर सकते हैं फॉर इन्वर्टिंग ऑपरेशनल एम्पलीफायर सर्किट। So this is all about regarding inverting operational amplifier. चलिए नेक्स्ट हम देखते हैं नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर सर्किट्स के बारे में। The second basic configurations of the operational amplifier circuit is that of non-inverting operational amplifier design. In this configuration, the input voltage signal Vn is applied directly to the non-inverting input terminal. Non-inverting input terminal क्या होता है हमारा, प्लस साइन से हम रिप्रेजेंट करते हैं उसको, which means that the output gain of the amplifier become positive in the value. In contrast to the inverting amplifier circuits we saw in the last tutorials or last lecture, whose output gain is negative in value. So the result of this that the output signal is in phase with the input signal. तो हम बोल सकते हैं कि जो हमारा आउटपुट सिग्नल है वो हमारा इनपुट सिग्नल के साथ सेम फेज में होता है, इसीलिए हम इसको नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर सर्किट बोलते हैं। Feedback control of non-inverting operational amplifier is achieved by applying a small part of the output voltage signal back to the inverting input terminal via RF minus of R2 voltage divider network, again producing negative feedback. This closed loop configuration provides a non-inverting amplifier circuit with very good stability, a very high input impedance, Rin approaching infinitely, as no current flow into the positive input terminal, or we can say that this is the ideal condition, and a low output impedance R out as shown in a figure. So the next topic is non-inverting operational amplifier configuration. So this is the circuit diagram for non-inverting operational amplifier. अब इसमें हम इनपुट कहाँ प्रोवाइड करा रहे हैं, नॉन इन्वर्टिंग टर्मिनल पे हम इसको इनपुट जो है प्रोवाइड करा रहे हैं. सो दिस इज कॉल्ड दी नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर. In the previous inverting amplifier lecture or tutorial, we said that for an ideal operational amplifier, no current flow into the input terminal of the amplifier, and that V1 always equal to V2. This was because the junction of the input and the feedback signal V1 are at the same potential. In other words, the junction is virtual earth summing point because of this virtual earth node of the resistor RF and R2 from a simple potential divider network across the non-inverting amplifier, with the voltage gain of the circuit being determined by the ratio of R2 and RF as shown in the figure. So this is the diagram for equivalent potential divider network. Then using the formula to calculate the output voltage of a potential divider network, we can calculate the closed loop voltage gain AV of the non-inverting amplifier as V1 is equal to R2 divided by R2 plus RF into Vout. Ideal summing point V1 is equal to Vn. And the voltage gain AV is equal to Vout divided by Vn. Then the gain, or we can say that voltage gain AV is equal to Vout divided by Vn, put the value, so is equal to R2 plus RF divided by R2. Transpose to given voltage gain is equal to Vout divided by Vn is equal to 1 plus RF divided by R2. Then the closed loop voltage gain of the non-inverting operational amplifier will be given as, so the AV is equal to 1 plus RF divided by R2. We see from the equation above that the overall closed loop gain of the non-inverting amplifier will always be greater but never less than unity. It is positive in nature and it is determined by the ratio of the value of RF and R2. If the value of feedback resistor RF is 0, the gain of the amplifier will be exactly equal to the 1, or we can say that unity. If resistor R2 is 0, the gain will approach infinite. But in practice, it will be limited to the operational amplifier open loop differential gain. We easily converted an inverting operational amplifier configuration into the non-inverting operational amplifier configuration by simply changing the input connection. इनपुट कनेक्शन को हम सिंपली चेंज करके इन्वर्टिंग को नॉन इन्वर्टिंग में और नॉन इन्वर्टिंग को इन्वर्टिंग ऑपरेशनल एम्पलीफायर में कन्वर्ट कर सकते हैं. So the next topic is the voltage followers, or we can say that unity gain buffer circuit. If we made the feedback resistor RF equal to the 0 and RF is equal to 0 and the resistor R2 equal to infinite, then the circuit would have a fixed gain of 1, as all the output voltage would be present on the inverting input terminal, or we can say that negative feedback. This would then produce a special type of the non-inverting amplifier circuit called voltage followers and also called a unity gain buffer circuit. As the input signal is connected directly to the non-inverting input of the amplifier and the output signal is not inverted, resulting in the output voltage being equal to the input voltage. So Vout is equal to Vn. This then makes the voltage follower circuit ideal as a unity gain buffer circuit because of its isolation properties. तो अगर हमारी RF की वैल्यू 0 होती है और R2 की वैल्यू इन्फिनिटी होती है तो इस कंडीशन में हमें फिक्स्ड गेन मिलता है जिसको हम यूनिटी गेन बोलते हैं. और ये एक स्पेशल टाइप का एम्पलीफायर सर्किट, नॉन इन्वर्टिंग एम्पलीफायर सर्किट क्रिएट करता है जिसको हम बोलते हैं वोल्टेज फॉलोअर्स, और इसको हम यूनिटी गेन बफर सर्किट भी बोलते हैं. So in this non-inverting circuit configurations, the input impedance Rn has increased to infinite and the feedback impedance Rf reduced to 0. The output is connected directly back to the negative inverting input. ये देखिए डायरेक्ट आउटपुट को ये नेगेटिव इन्वर्टिंग इनपुट में कनेक्ट किया हुआ है विदाउट एनी रेजिस्टेंस. The output is connected directly back to the negative inverting input, so the feedback is 100% and Vin is exactly equal to Vout, giving it a fixed gain of 1 or unity. As the input voltage Vn is applied to non-inverting input, the gain of the amplifier is given as, so Vout is equal to A into Vn, or Vn is equal to V plus and Vout is equal to V minus. Therefore, the gain AB is equal to V out divided by V in. So we get +1. Next is a non-inverting voltage followers. Since no current flow into the non-inverting input terminals, the input impedance is infinite for ideal operational amplifier, and also no current flow through the feedback loop, so any value of the resistance may be placed in the feedback loop without affecting the characteristics of the circuit, as no voltage is dissipated across it, zero current flow and zero voltage drop and zero power loss. As the input current is zero, giving zero input power, the voltage followers can provide a large power gain. However, in most real unity gain buffer circuit, a low value, typically 1 kilo ohm resistor, is required to reduce any offset input leakage current, and also if the operational amplifier is of a current feedback type. The voltage followers or unity gain buffer is a special and very useful type of non-inverting amplifier circuit that is commonly used in electronics to isolate circuits from each other, especially in high order state variable or Salon key type active filter, to separate one filter stage from the other. Typical digital buffer ICs available are 74LS125 and quad 3-state buffer, or more common 74LS244 octa buffer. ये कुछ वोल्टेज फॉलोअर्स बफर्स सर्किट्स के टाइप्स हैं. One final throw. The closed loop voltage gain of the voltage follower circuit is 1 or unity. The open loop voltage gain of an operational amplifier with a feedback is infinite. Then, be carefully selecting the feedback components. We can control the amount of gain produced by non-inverting operational amplifier anywhere from 1 to infinity. Thus far we have analyzed an inverting and non-inverting amplifier circuit that has just one input signal Vin. In our next lecture about operational amplifier, we will examine the effect of the output voltage Vout by connecting more input to the amplifier. This then produce another common type of operational amplifier circuit called as a summing amplifier, and which can be used to add together the voltage present on its input. नेक्स्ट वाले लेक्चर में हम यही स्पेशल डिजाइन समर, एडर, सबस्ट्रैक्टर, डिफरेंशिएटर और इंटीग्रेटर टाइप्स के हम ऑपरेशनल एम्पलीफायर सर्किट को स्टडी करेंगे. This is all about inverting and non-inverting operational amplifier, and finally the references of this presentation. So these are the references. And thank you for watching this video.